My dear student, how are you? I think all of you are well. Today I am going to conduct another class. So welcome to Amader Pashala presented by Manipur Uccho Vidyalaya and College. Before going to my main lecture, I would like to inform you about my previous lecture. So this is the review of my previous lecture. In my previous lecture, I already told about Kirchhoff's law. You already learned it. This is a first theorem, that is junction law, and you know that at junction the total current at junction becomes 0. And another one is, this is a complex circuit because this circuit contains more than one resistances and more than one cells, but there is no combination between the cells and the resistance. In this case, how can you calculate the current I1 and I2? You have already learned from Kirchhoff's law. And finally, you have learned about the application of Kirchhoff's law. This is the most important application of Kirchhoff's law, and you know that this is a Wheatstone bridge. In this circuit, by using Kirchhoff's law, you can know about the balance of the circuit. That means at what condition the circuit will be balanced, that means no current will flow through the galvanometer. You have already learnt it. So this is my review of my previous lecture. Now what I am going to learn today. My today's topic is effect of temperature on resistances. Chapter 3, current electricity, lecture number 3, physics, second paper for class 11 and 12. So what are the learning outcomes? At the end of the lecture, the student will be able to know about what is the effect of temperature on resistance, why does resistance of semiconductor changes with the change of temperature, and why does resistance of two wires are different, and finally they will be able to solve some mathematical problems and creative questions that helps them to make a better result in the examination. My dear students, in my previous two classes you have learned about so many things about resistances, but basically what is resistance? You don't learn this. In my today's lecture, I am going to discuss what are the resistances and the dependency of resistances. That means on what factors basically resistance depends. You know that there are 4 factors on which the resistance of a material depends. Number 1, the length of the conductor. That means is the length is short or longer, on which resistance basically depends. Number 2, cross sectional area of the conductor. That means the area of the conductor is thin or coarse. And number 3, the materials of the conductor. That means at which material the conductor is made of. That means is it copper or silver or aluminum. And fourth one, the temperature of the conductor. So basically our today's lecture depends on temperature of the conductors. Laws of resistance. In order to know the dependency of this resistance, you have to learn about the laws of resistance. First law, you know that there are 4 laws on the resistances, and the first law is known as law of length. In this case, just you know about the relation between resistance and the length of the conductor. So only resistance and length will relate this law. All other quantities remain constant. That means the temperature remain constant, the cross section area of the remains constant, a material of the conductors remains constant. Then what will be the relation between resistance and length? And this is are proportional to L. That means the more the length of the conductor, the more the resistance of the conductor. That means if you have take 2 conductors, one is 1 meter length and one is 5 meter length having same cross section area at same temperature, then you will get the conductor whose length is 5 meter will be give the more resistances. And the second law is law of cross sectional area. So similar discussion that I have just in this case, this law relation between cross sectional area and the resistance. So all other quantities, that means the length of the conductor, remains constant, the temperature of the conductor remains constant, and the material of the conductor remains constant. All these three quantities remain constant, then the resistance of the conductor is inversely proportional to its cross section area. That means the more the area, the less the resistance. So, if you take two wires, one is coarse, another is thin, in this case you will get more resistance to the thin wire. And number 3, the laws of material. That means, in this case this law basically relates the material of the conductor and the resistances. In the similar way, temperature of the remain constant and length of the conductor remains constant, cross section area of the material of the conductor remains constant, then the resistance for different material will be different. That means, you have given two wires having same length, same cross section area and same temperature, but one is copper and another one is aluminum. In this case, you will get two different resistance, though all these three quantities remain constant. So, this is because these two conductors are different in materials. Now, finally, what we have got in the first law, we relate R proportional to L when A is constant, and second one we get R proportional to 1 by A when L is constant. When both are constant, when both length and A are constant, then we can write R proportional to L by A. And now, for simple mathematics, we can write R equals to constant into L by A. As you know that to get proportional from equal, we have to take a constant. And what will be the constant in this case? The constant is nothing but this is, and you know that this is the rho, where rho is the specific resistance of the conductor. Basically, rho it differ for different materials having same length and cross section area at a particular temperature. So, basically rho describes the property of the materials. Now, what basically means rho? That is a specific resistance. What is meant by the specific resistance of copper 1.56 10 to the power minus 8 ohm meter? What basically mean this? That means if the length of a copper is 1 meter having 1 meter square area, then the resistance of the conductor will be 1.56 10 to the power minus 8 meter. I repeat, if the length of the copper wire is 1 meter having unit area, cross section area at a particular temperature, then its resistance will be 1.56 into 10 to the power minus 8 ohm. This can be written simply in this way. That is rho equals to R by A, where R denotes the resistance which becomes 1.56 10 to the power minus 8 ohm, and A becomes 1 meter square and L becomes 1 meter. Then finally, you get 1.56 10 to the power minus 8 ohm meter. My dear student, you must have mentioned here the temperature remain constant, that I cannot show it in my mathematical expression. So, in this case temperature must be constant. Now, the opposite property of the resistivity is known as conductivity. For your kind information, I am interested to describe this. The property of the material for which the electricity can flow through the conductor is called conductivity. It is denoted by sigma. This is the opposite of resistivity, that is rho sigma equals to 1 by rho, and its unit will be ohm meter to the power minus 1, that is Siemens per meter. You know that conductance is the opposite of resistance. I repeat it, conductance is the opposite of resistance. That means the unit of resistance is ohm. So, what will be the unit of conductance, not conductivity? So, conductivity unit of conductivity will be Siemens per meter or Siemens per meter. Now, the effect of temperature on resistance, that means if we take a conductor at different temperature, then what will be its resistances? This will be described in a simple mathematical graph. You know that this is a graph where x axis basically denotes temperature and the y axis basically denotes the resistance, and this is a relation between temperature and resistances, in this case this portion is the initial resistance, that is R naught. That means the temperature at which any material show in its 0 temperature. That means if the conductor is in 0 temperature, then this is its initial resistance, and with the increase of resistance, with the increase of temperature, resistance will be increased in a linear way. That means from this it is very clear that with the increase of temperature, resistance will be increased, but this is not appropriate or correct for all the metals. You know that conductors basically are of 3 types. Metals are basically of 3 types. Number 1 is conductor, another one is semiconductor, and third one is insulator. So what are the effect of temperature on these 3 materials? Number 1, this is the conductor, you know that this is the semiconductor, and third one is insulator. In this case, with the increase of temperature, for your kind information, you know that this is the band theory. According to band theory, you will learn band theory in chapter 10, that is semiconductor and electronics, but I am interested to describe this here in a simple way. You know that basically in a conductor, the valence band and conduction bands are in overlapping form. So when temperature increases, then these electrons makes more collision, for which the resistance will be increases. But in semiconductor, there is a band gap. If temperature increases, then electrons jump from valence band to conduction bands, which creates electricity. And for insulator, the band gap is more wider. That is why electron cannot jump, cannot reach to the conduction by jumping. That is why with the increase of temperature, the conductivity of semiconductor will be increases, but not conductor. That means with the increase of temperature, the resistance of conductor will be increases, but semiconductor will be decreases. Now, the temperature dependency of resistance, especially for the conductor, establish a relation, but how can we establish the relation? For simply you have to consider the resistance of at 0 degree Celsius, the resistance of a conductor is R naught, and any temperature theta, if the resistance of the conductor is R theta, then the increase of resistance is R theta minus R naught. So, what is the change in temperature or increase in temperature? That is theta minus 0, that becomes theta. According to thermometric property of the resistances, or from laboratory, you can write R theta minus R naught proportional to R naught theta. This is the simple relation that we get from experiment or thermometric property of the resistances. And now, we can simply mathematics, we can write R theta minus R naught equals to constant into R naught theta. Then in this case, the resistance is this constant is alpha. Then finally, mathematically you can write R theta equals to R naught plus alpha R naught theta. So, this is the relation. In a simple way, you can write R theta equals to R naught 1 plus alpha theta. So, this is the relation with the increase of temperature of resistance of a conductor, only for the conductor. And there is something new comes here, that is alpha. Now, I am going to discuss about alpha. Alpha is basically known as the temperature coefficient of resistance. So, what basically temperature coefficient of resistance? What is mean by temperature coefficient of resistance of aluminum 3.9 10 to the power minus 3 per degree Celsius? My dear student, you can write per Kelvin also. Per Kelvin and per degree Celsius, in this case both are same. So, what basically indicates the resistance coefficient of resistance of aluminum of 3.9 10 to the power minus 3 per Kelvin or per degree Celsius. In my next slide, you will get the answer, and this is the next slide. The temperature coefficient of resistance of aluminum of 3.9 10 to the power minus 3 per degree Celsius means that if the temperature of aluminum conductor having 1 ohm resistance at 0 degree Celsius is increased by 1 degree Celsius, then its resistance will be increased by 3.9 into 10 to the power minus 3 ohm. That means, if the resistance of aluminum at 0 degree Celsius is 1 ohm. At 0 degree Celsius, the resistance of aluminum is 1 ohm. And if you increase the temperature of the aluminum by 1 degree Celsius, then you will get the resistance of the aluminum will be 3.9 10 to the power minus 3 ohm. So, this is the temperature coefficient of resistivity. And simply mathematics, you can write alpha equals to r theta minus r naught theta, putting the value of r theta minus r naught. So, this is the increase of resistance, and r naught from the definition, r naught will be 1 ohm, and del theta or simply theta, that is the increase of temperature, and this will be 1 degree Celsius or 1 Kelvin. Then from this calculation you can write 3.9 10 to the power minus 3 per degree Celsius. So, this is the temperature coefficient of resistivity or resistance. Now, a simple mathematical problems for you, but do not worry, there is also a solution. Resistance of a conductor at 0 degree and 100 degree Celsius are 4 ohm and 6 ohm respectively. Calculate the resistance of the conductor at 150 degrees Celsius. In this case, the resistance of a conductor at two different temperatures are given, and you have to calculate in another new temperature 150 degrees Celsius. But my dear student, you have learned that r theta equals to r naught 1 plus alpha theta. In this case, alpha is not given. So, you can solve by calculating alpha or by forming two equations for two different resistances. You can solve this problem, but a simple one is for you. This is the solution. So, what is the given resistance at 0 degree Celsius is 4 ohm, and at 100 degree Celsius is 6 ohm. You have to calculate resistance as 150 degree Celsius, or 150 equals to what? Then using mathematical formula you can write r 100 equals to r naught 1 plus alpha theta, alpha equals to r 100 minus r naught theta, r naught. In this case, putting the value of r 100, r naught and theta r naught, you will get 0.005 per degree Celsius. So, this is the temperature coefficient of resistance, and using this temperature coefficient equation in this similar equation, you will get the resistance at 150 degree Celsius. Now, just have a look in my next slide, and this is again 150. So, this is the calculation that I have already told. R 150, this is the temperature, they basically that denotes the theta, and r naught 1 plus alpha theta. In this case, r naught, this is the initial resistance at 0 degree, 4 as given, and 1 for simply mathematics, and theta 150 degree Celsius, and alpha which is calculated in my previous slide. Then simply mathematics, doing simple mathematics, you will get r 150 equals to 7 ohm. So, this is the required answer. That means resistance of the conductor at 150 degree Celsius will be 7 ohm. Now, I am going to discuss another effect of resistance. You know that when electrons makes collision, then they also create resistance, but when current flow through any conductor, they also produce heat. That means due to the different cases. Now, what are the effect of heat produced depend on the resistance. Not only the resistance, production of heat in a conductor basically depends on three factors, that is amount of current and the resistance and how long the current flow through the conductor. So, these are the three parameters, number 1 current, number 2 resistance, and number 3 how long the current flow through any conductors. So, Joules is a fundamental scientist who established the relation, that is why this is known as Joules law for heating effect, and this law basically relates among these three parameters with the heat, that is I, R and T. Now, I am discuss the first law of Joules. At the first law, you know that if the resistance of a conductor and time of flow of current remain constant, then the heat generated due to flow of current is directly proportional to the square of the flowing current, that is is proportional to I square. That means generated heat is directly proportional to the square of the flowing current when resistance and time both are constant. That means if resistance and time remain constant, then produced heat will directly proportional to the square of the flowing current. And the second law, you will learn that produced heat or generated heat is directly proportional to the resistance. In this case, all other quantities, that is current and the time must be remain constant. Then what will be the language? If the current and the time, this is current and time of flow remain constant, then heat generated or produced in a conductor is directly proportional to the resistance. That means the more the resistance, the more the heat produced. And number 3, the law, that is law of time. In this law, you know that heat is directly proportional to the time. That means the more the time you will conduct electricity, the more the heat will be produced when I and R both are remain constant as before. So, what will be the language of the third law of Joules? If the resistance of a conductor, current carrying conductor and flow of current remain constant, then heat generated in a conductor is directly proportional to the flow of time. Basically, this is the summarized form. You can write from this equation if you bear in mind. Now, these three laws can be combined form and written as H proportional to I square RT. Then simply mathematics, H equals to K I square RT, where K is the constant. If R is measured in ohm and T is second and I is in ohm ampere, then H becomes K becomes 1 and the unit of heat will be in joule. That is H equals to I square RT when I, R and T, all these three quantities are measured in SI unit. That means if you use ampere in current, resistance, ohm in resistance and second in time, then you will get the unit of H produced heat is joule. Again, this law can be written H equals to I square RT 4.2 joule per calorie. That means 0.24 I square RT. That means if you write, if you use all this quantity are in calorie, then you will get calorie. That means if you want to calculate heat, produce heat in calorie, then you have to write 0.24 I square RT. You know that K and J are the opposite property. That is from first law of thermodynamics, you know K equals to 1 by J and J equals to 4.2 joule per calorie. That is the temperature joules constant. That means mechanical equivalent of heat that you have learned in chapter 1 thermodynamics. So, this is the format for the joule unit and this is the format for calorie unit. So, this is the equation of Joules theory of production of heat. So, my dear students, in my today's lecture I have already learned about the dependency of resistances, and then we have learned what is the produced heat if a current flow through a conductor, and you know that heat produced basically depends on the amount of flowing current, what is the resistance of the conductor and how long current flow through the conductors. So, all these three quantity are responsible for the production of heat in a conductor. I think it is very clear to you, you already know why the conducting wire becomes hot if it runs long time. And now do some mathematical problems related to my today's lecture. How long will it take to raise the temperature of water by 24 degrees Celsius if immersion heater of 100 ohm resistance is immersed in a water of 2.5 kg and 5 ampere current pass through the heater? That means, in this case the resistance of the heater is given and the amount of flowing current is given, and what amount of water is available here also mentioning here, and what is the temperature, how much temperature will be increased, this is also given. Now, a simple given that mass of the water, that is m equals to 2.5, specific resistance that is 4200 joule per kg Kelvin. You have to bear in mind, sometimes it does not mention in the question. So, you have to take in mind or memory. And what are the next, that is increase in temperature, that is del theta 24 degrees Celsius, that means 24 Kelvin, and the resistance R equals to 100 ohm, and you have to calculate how long the immersion heater runs. Now, you have to calculate T. Now, we know H equals to I square RT. In this case, my dear students, here T you have to calculate, I and R both are given, but H does not mention here. So, you have to calculate H by helping another formula that you have learned in first chapter, that is H equals to ms del theta, where m is the mass of the given sample. In this case, the sample is water, and number 2 the specific heat, and del theta, that is the change in temperature. Using these two equation, you can simply write I square RT equals to ms del theta. From this equation, T equals to ms del theta by I square RT. Putting the value of ms del theta, I and R, you will get time equals to 100.8 second. This can be written 1.68 minute. So, this is the required time for the immersion heater. And number 4, this is the time for the required. Now, my dear student, we have just reached at the end of my lecture, and a sample question for you, and you know this is a very important question, creative question. At normal temperature, my dear student, in this case normal temperature basically I mentioned here at 25 degrees Celsius, and the resistance of tungsten wire is 65 ohm. Coil of 2 electric heaters are made by this wire connected with the electric line of 220 volt. As a result, temperature of the coils reached to 250 degrees Celsius. The length and the diameter both of first wire are twice of those of second wire. Temperature coefficient of resistance of the wire is 4.5 into 10 to the power minus 3. So many information are given here, and in this case I just established relate two topics my today's lecture, that is heat generation and the relation of laws of resistances. So, what are the available question here? But before going to, I just repeat, this is the initial temperature, this is the resistance, and this is also the connecting voltage, this is the final temperature, and in this case this relate the radius and diameter of first and second wire, and these two heat are basically made by two simple same wire, and also given the temperature coefficient of resistances. So, what are the available question here? What is called a specific resistance? What is meant by the temperature coefficient of resistance of the wire at 4.5 10 to the power minus 3 per Kelvin, and C, find the temperature, find the resistance of the wire at 250 degrees Celsius, that means R theta, and finally you will coil will generate more heat between two heaters given in the stem. So, this is homework for you. So, no more today. Thanks all.